to the Massachusetts Institute of Dictator to see if Kevin will get it. Kevin gets in! This is the Walmart version of the Conservation of Momentum Lab produced by Kevin Wu and Jack London.
So for this recreation of the lab, we used very convenient Lego Duplos that I had. And what's nice about these is that they're Legos, so you can stick any blocks on top, change the weight, change the mass for your data. And then you can obviously change the velocity, and most of the time you just use the same velocity by using these launchers that I also had as part of the kit. So I'll do a demo here. Just the launcher launches it really fast. And the track is very frictionless too, which is nice for data collection purposes. Then Kevin will talk about the magnets.
Yeah, so for the magnets, if you want to, this right here, right, they stick onto each other. If you want them to repel, to have like a bounce situation, you can simply reverse the magnets. So now they will repel each other instead of sticking onto each other. So when we have like a bounce situation, we don't want to use the launchers because they'll be too strong for this. I'll show you what happens if you actually use the launchers. When we do use the launchers, what will mostly happen is one or two of the cars, or both of the cars will fall off the track. So we want both of them to stay onto the track, and we don't want them to hit each other. So the way we do that is by using our hands and just give them like a gentle push, like that. So this way they will both be on the track and they won't hit each other. Therefore we'll have like a pretty nice data for bounce. And as for stick, as I mentioned earlier, you just reverse the magnets, and now they'll stick onto each other. This thing, it pulls the magnets off. But basically, for like a stick situation though, it doesn't really matter if you use your hands or the launcher. You can use your launcher because they will stick onto each other no matter what. I'll show you.
Okay, quick tracker demonstration to show how we got the velocities. First you're going to need a calibration stick for frame of reference. For me, I knew that this brick up here was exactly 0.127 meters every time, obviously. So just drag like that, and then you set your length to 0.127. And then you track the point mass, which would be on the car somewhere, to see how fast it's going within that frame of reference. So we go to track new point mass, and this is the car that's going to be running over here, so I'll just track it, but I need to get the video to the correct part right before it starts moving. That's going to be right there, and I'm going to start tracking this. It's okay, it's not moving at first. There, now it's moving, so I can track the same part of the vehicle. And there it made contact, still moving forwards. Gonna track it a little bit longer. Don't need anything crazy. Okay, that's good. Now I'm gonna go to the graph that I just created, and you can see that there's kind of two different slopes going on here. And the first slope, which would be like here to here, is its initial velocity. So I highlight those points, I hit analyze, curve filter, line of best fit, and you can see there that the slope is negative 0.0208 meters per second. And then the second part, after it collides with the second vehicle, is obviously going to have a different velocity, and that would be the slope of these points right here. So I'm going to hit analyze again, or actually this time just that button, and I can see now that for the second portion of the collision, when the two cars were stuck together, it has a velocity of negative 0.065 meters per second, and then those are the velocities that you just plug into Google Sheets.